Welcome to ScenarioSolver. We're looking at analytical game 4 of PrepTest 63, June of 2011. A street entertainer has 6 boxes stacked one on top of the other and numbered consecutively 1 through 6 from the lowest box up to the highest. Each box contains a single ball, and each ball is one of 3 colors: green, red, or white. So G, R, or W. Onlookers are to guess the color of each ball in each box, given that the following conditions hold. There are more red balls than white balls, so we have more R than W. There is a box containing a green ball that is lower in the stack than any box that contains a red ball. So basically G1 must occur before R1. And then lastly, there is a white ball in a box that is immediately below a box that contains a green ball. Okay, so we have a block of WG. Now, this can appear vertical to you. I'm just going to craft this in a horizontal manner. And let's take a look at what we can come up with here. Okay, so as always, we want to utilize the hierarchy of rules to solve the scenarios. We have no first order rule here. We have a second order rule, okay? But we have bigger fish to fry in this game. We don't know the variables that are actually going. We don't know how many G's or how many R's or how many W's. So what we need to do is try to assess what that will mean, how many of each or what must go. So let's just take a look at what we know goes. All right, we know that W and G, this block must occur. Okay, we know that that has to happen. Then the question becomes, what else must occur? Well, we know that there is more R than W, so we know that we have at least 2 R's. Now, after that, we don't know, okay? We have no idea. So we know 4 of the 6. Looking at that, we know only 4 of 6 variables. We have no first order rule. We only have a second order rules. We really need to consider the idea that we can't solve this thing. We don't think that we'll be able to, and we just want to create some scenario templates. So let's do that. We're just going to distribute our second order rule . Okay, so we know that we've got 5 of these to work from. That's got to be true with any question that we face. But now let's take a look and see if we can fill anything in. We know the one on top, we know that there's 2 R's there. We don't know anything more. But let's take a look at this one. We know that an R can't go here because we have to have a G1 before an R1. So in either a W or a G can occur. So let's just make that actually happen. Okay, and in this situation, we know that we'd end up with like this: R, R, and R. Now here, we could end up with an R and an R and an R, or an R and an R and an R and a G. We don't know anything past that, so we're just going to kind of leave that as is. Now let's take a look at this one. The question becomes, you know, is it the same thing? Can we put a G and a W there? All right, so what would happen if we were to put a W right here? Okay, if we were to put a W there, we'd have to use 3 R's because we have to have more R's than W's, and that would make it where G1 didn't occur before R1. So we know for a fact that we have to have G right here. And then it's the same as here and the same also as there. Okay, after this, you know, at this point in time, there's just so many more things that can happen in this game. For example, here we could have 3 R's here. We could have a G here and 2 R's. We could do a lot of things. We know that we can't have a W here. We know that we can't have W's in these situations. You know, a 1 up here, we could have a W here and 3 R's. It's just really wide open. But what we have created are 6 scenario templates. from which to work, one of which is totally solved. Now, you might have noticed that I kind of presupposed that I could solve this. When I was originally doing this game, on pencil and paper, I just initially went across here, but I realized very quickly that if I broke these apart, I could solve one of them. So, I just was able to cram it in there, which you'll be able to do during test time, but I needed to open this up so we could all see it. Okay, let's go to the questions. If there are exactly 2 white balls, then which one of the following boxes could contain a green ball? All right, so the question becomes, in what situation can we have 2 white balls? All right, could we have 2 white balls after this point in time? And the answer to that is absolutely not, because if we did, we'd have 2 green balls, 2 white balls, and only room for 2 red, 2 R's. But we can have 2 whites in scenarios 1 and 2. Okay, so we're looking at scenarios 1 and 2. So which one of the following could contain a green ball? It would either be box 2 or 3, and as such, the answer to the question is B. Understand again, below the first 2 scenario templates, you cannot have another white because you already have 2 greens. You'd need 3 reds. You'd need 7 total variable spots, and we don't have that. Okay. 19. If there are green balls in 5 and 6, which one of the following could be true? Okay. So what we need to do here is come down and use our scenario templates that we've created. So if we have green balls in green in 5 and 6. Where can that happen? Well, it could happen in scenario 1. If you look there, we could have a WG there, and we'd end up with actually 2 R's. We could not do it with this one because we would not have enough red. Okay, could we do it here? The same situation would happen. Okay, but the same situation would happen because we would have only 1 room for red here. But we could do it with scenario 5. We could have a G and then 2 R's. Okay, so that is the only thing that can happen within the context of question 19. So which one of the following could be true? There are red balls in 1 and 4. That cannot be true. There are red balls in 2 and 4. That cannot be true. There is a white ball in box 1. Absolutely, it can happen right there. The answer to the question is C. And then D, there is a white ball in box 2. That cannot be true. And then E, there is a white ball in box 3. That cannot be true either. We have proven that the answer to the question is C. All right, the ball in which one of the following boxes must be the same color as at least one of the other balls? Okay, so basically the question becomes, which box is it a requirement that that box be the same color as something else? Okay, well, a good way to think about this is take a look at, let's look at box 2 real quick. Does box 2 need to be the same color as every other box, right? Well, if you look at W here, right, we already said we could fill this all up with red, right? And so W would be alone in scenarios 3, 4, 5, and 6, which means that boxes 2, 3, 4, and 5 do not have to be the same color as any other box. But box 6, on the other hand, no matter what we do, box 6 would need to be the same color as this. Here we could either put a G or an R, that would have to be the same color. G or an R, that would also have to be the same color. The same with here also. So we know that it's box 6 that is required, that there's a requirement that it be the same color as another. And if you look here, if we ended up with a red here, we'd have to have a red somewhere else. If we ended up with a W, we have already got another W. And if we ended up with a green, we've already got another green. So it is true, it must be true that box 6 is the same color as at least one other box. Okay, 21. Which one of the following must be true? A, there is a green ball in a box that is lower than box 4. Well, these are all our scenario templates. All right, take a look. We have a green. We have green in at least every single one, actually before box 3. Thus, A is the correct answer to the question. That must be true. Let's look at B, though. There is a green ball in a box that is higher than 4. Well, if you look here in 3, we could do all reds right here. There is no green ball in a box that's higher than 4, so B is out. Let's look at C. There is a red ball in a box that is lower than 4. Well, in this one right here, we could put a G here and 2 R's, and we would not have to have a red that's lower than 4, so that falls out. D, there is a red ball in a box that's higher than 4. Okay, well, let's take a look at that. Does that have to be? We could put 2 reds right here and then another green here, and there would be no reds that are higher than box 4. So that does not have to be true. As such, it is not the answer to the question. And then E, there is a white ball in a box that is lower than box 4. Well, here we have a white ball in box 5. We could put all R's there, so it is not a must be true that we have a white ball in a box that is lower than 4. Okay. Let's look, and again, so the answer to the question is A. 22, if there are red balls in boxes 2 and 3, which one of the following could be true? Okay, well, so let's come over here. And take a look, where could that happen? Where could we have red balls in boxes 2 and 3? It's right here. Okay, that's it right there, so let's take a look. So which one of the following could be true? We'll look at A, there is a red ball in box 1. No, that has to be green. B, there is a white ball in 1. No, again, it has to be green. C, there is a green ball in box 4. Right here, we could put a green ball in box 4. Thus, C is the correct answer to the question. Let's look at D, though. There is a red ball in box 5. No, it's either G or W. E, there is a white ball in box 6. Well, it seems like that could be the case, right? But if we put a white ball there, we would not end up with 3 reds. So that cannot be true. This will not work. Okay, so we know for a fact, again, that the answer to the question is C. 23, if boxes 2, 3, and 4 all contain balls that are the same color as each other, then which one of the following must be true? Okay, so all right, where can we create a situation where 2, 3, and 4 all have the same color, okay? Well, it could happen in 6. We could have G, and then with the W and the G, we could have 2, 3, and 4 just like that. That can happen, okay? It cannot have, we can never have 3 W's. We could never have anything there. But if we look here, we have the W, and then the 2, 3, and 4. And then we could end up with the red and red. So it can happen. It comes from scenarios 1 and 6, and that's what we end up with. So which one of the following must be true? Exactly 2 of the boxes contain a green ball. Well, no, doesn't have to be true because we had 3 green balls there. B, exactly 3 of the boxes contain a green ball. That doesn't have to be true because we have 3 reds in this and only 2 greens. C, exactly 3 of the boxes contain a red ball. Well, no, there are only 2 in this scenario. D, exactly 1 of the boxes contain a white ball. Absolutely, we have 1 of the boxes containing white balls in both of our scenarios, so D is the answer to the question. But let's look at E, though. Exactly 2 of the boxes contain white. That cannot be. If we ever had that, we would not have enough room to create what we needed to create, so that cannot be true. Okay, that concludes Analytical Game 4, LSAT 63, June of 2011. Thanks.